Machines, computers, smartwatches, they're on pockets, on our wrists, they're everywhere. We've reached a point where we can even inject them into our bodies. And it's taken as a norm now. It's the new norm. But they're not without their flaws, because sometimes we get things like this. Because we can all wait 46,000 days for a few files to load up. Nothing is wrong with that. Now, situations like this are what made me think, what if we could add a brain to our computers? If we think about it, a processor is nothing but a flattened rock with electricity in it. That's it. And we've reached a level where it can do complex mathematical operations, we can play videos, play games, whatever it is. So having a human brain implemented in it, is it that far of a shot? Now, this does exist, and it's called a neural network. A neural network, two very big words, but it's as simple as it sounds. A human brain that is modeled in a computer. Now, there was a lot of digging done around trying to find a very simple example about what a neural network looks like. The best example was something like this. Not very pleasant. Now, after more digging, I found this. This is the simplest way to describe a neural network. It's blocks, neurons, just like in your brain. Each does a simple operation, and they're connected to each other in a way that makes them function like a human brain by inputting data and outputting a result. How does that work? Each neuron is modeled something like this. You have the input. Could be a number, yes or no, whatever it is, it's a piece of data. And that data is used by a weight. Now what the weight does is that it calculates a probability. What is this probability? Think of it as this. I have a bag full of marbles. The marbles are of different colors. How likely is the marble going to be red if I pull out one at random? That is my weight. It's a simple probability that calculates how likely is this input going to be correct, or how important is it to me? After the input is used by the weight, it moves on to the sum. What the sum does is that it calculates all the weights together and gives me one value. That one value is the result of the neural network. That one value is the one that I need. But how can I find out that this value is actually reliable? That's where the threshold comes in. Lucky for us, sometimes we can train a neural network. By training a neural network, you train it just like a brain. You keep going and let it do its thing and tell it, this is right, this is wrong, you fix this, you keep doing that. The threshold is like the answer we have, the predetermined answer, the one we give to the machine. This is right and this is wrong. By comparing both answers, we finally get the output, which could be the threshold or it could be the actual sum. Now, yes, this is not reliable the first time around, but this keeps repeating in a cycle, on and on and on, and the results keep getting more accurate. It looks something like this. This is a neural network running on the provided pieces of data to find a pattern. At first, the estimation is way off, but as the cycle repeats on and on and on, it gets more accurate. And the power of this is endless. Just by having completely random data, we can find a pattern just using a few iterations. And yes, this is after it's being trained. Now, this is where I'm done with all the boring talk. No more science talk here. How does this actually fit in our lives? How does this affect me and you? What if I told you that we can actually have a full conversation with robots that are not used by humans on the back end? In Google I/O 2018, last year, there was a demo of a full robotized conversation between a human and an automated machine. It goes like this.
See, how may I help you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people when?
Next Wednesday at 6 p.m.
Oh, actually we reserve for like after like 5 people. For 4 people you can come.
How long is the wait usually to be seated?
For when, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Bye-bye.
Now, if I ask for a show of hands, which machine, which side of the conversation was the machine? How many of you would say right? Show of hands. Well, on the left side was the machine. The left side was 100% automated with no human involved. The only human interaction involved in this was prior to the conversation, and it went something along the lines of, "Hey Google, book me a reservation on Wednesday the 7th at restaurant under the name of whatever it is." That is all the human needed to say. And this is what we have reached using a simple algorithm of a neural network. In a few years' time, we could all be talking to robots without even knowing that we are talking to them. Now, obviously, this is not how it started off. This is after years of development. The first consumer version of a neural network was actually in Microsoft's iconic Kinect. It was a revolution because it involved a neural network that was trained in months. It took months to train this neural network. Millions of cycles of iterations going on and on and on with wrong answers and correct answers. Now, what does it do? It takes a video of a human, something like this, and transforms it into this. Lines, colors, and symbols. This is how you could control Microsoft's Kinect just by moving your hand. And the work that has gone behind this was immense, feeding it photos, videos, live footage of people just walking around, just so that you could identify it. Just like how you train a baby to identify a square from a circle. Cars. We've all heard of Tesla, the self-driving electric car. Yes, that is a thing. And this is what goes on behind the scenes. The car is equipped with many sensors, and Tesla isn't the only one that's equipped with self-driving. But here is how it goes. It takes footage of everything around it, and it identifies the car. This goes again into training a neural network. Not only does it identify the car, it identifies how far it is, it identifies its direction, and what should it do with that car? Is it a threat or not? It can identify pedestrians walking down the street to stop and let them pass. In future updates, it's expected to identify traffic lights. It's expected to identify lanes. It has huge impact on us. We have reached a stage where we do not need to drive our own cars. As of right now, yes, this does require some human interaction, but it's not as much as you'd expect. In the future, we are going to be lending our lives over to machines. We would not have to really think about the simple things we do in life. Everything is going to be automated. A machine is going to do things for us. Netflix. Probably the one thing we all use here. Now, Netflix recommendations are not as random as you may think they may be. Yes, you don't like all of them, but there's a neural network behind this. It's not someone that goes on and be like, oh, he likes this, so he'll probably like that, or oh, I like this, everyone should like that. This is a neural network that takes in all the videos, all the movies you watch, and it says, yes, he liked that. Yes, he disliked that. He didn't watch this till the end, so he didn't like it. And it gives you recommendations based on that. If you like this, you'll probably like this one. If you didn't like this, then you won't like all the others. And so when Netflix recommends Bandersnatch to all of us, it's not just because someone wants it to, it's because we probably should watch it. It's probably a good thing. Our future is going to be automated by neural networks. And we will not even realize it, even when we're there. We're taking huge steps forward to a level where there are over 40 million homes as of right now that are equipped with smart speakers. Speakers that you talk to and they reply back. Machines replying back to you, giving you answers of Google searches, ordering you an Uber, telling you everything you might want to know. The future is not what we may expect it to be. Thank you.